Understanding the rules and regulations surrounding conduit installation is crucial, especially regarding who can perform this type of work. In Louisiana, as in many other places, specific guidelines exist. This discussion focuses on the steps taken to clarify these regulations, specifically concerning unlicensed individuals working with conduit. It's important to emphasize the distinction between conduit, which is the raceway, and conductors, which are the wires inside the conduit. The rules governing these can be different. Firstly, efforts were made to contact the Louisiana state licensing authorities. The goal was to obtain official clarification on the regulations pertaining to conduit installation by individuals who do not hold an electrical license. This involved clearly stating the inquiry focused solely on conduit work and not the installation of conductors. Secondly, attempts were made to reach out to the NOLA city services. The aim was to gather information on any local regulations specific to New Orleans and to explore potential training opportunities related to conduit installation. Unfortunately, reaching the right person who could answer these questions proved challenging. Thirdly, communication was initiated with a volunteer group. The intention was to leverage the network to arrange training sessions or meetings with city officials upon returning to New Orleans. These meetings would provide a valuable platform to discuss conduit installation regulations and explore potential training initiatives. Concurrently with these outreach efforts, work has begun on developing comprehensive training materials. These materials will serve as a resource for understanding the relevant aspects of conduit installation. The training materials will include several key components. One relevant excerpt from the National Electrical Code, or NEC, will be included. The NEC provides a widely recognized set of standards for safe electrical installations, and referencing it directly will ensure the training materials are accurate and up to date. 2. Illustrative drawings will be incorporated. Visual aids can greatly enhance understanding, so the training materials will feature detailed drawings created using 3D computer-aided design, or CAD, software to illustrate conduit bending techniques, proper installation methods, and other essential concepts. Moving forward, the next steps involve awaiting responses from both the state licensing authorities and the NOLA city services. The information received from these sources will be crucial in shaping the training materials and understanding the specific regulations in place. It also involves scheduling meetings with city officials through the volunteer group connections. These meetings will provide an opportunity to discuss the regulatory landscape and explore potential collaborations on training programs. Finally, finalizing the training materials and determining appropriate distribution channels is a priority. The goal is to make these materials accessible to anyone interested in learning about safe and compliant conduit installation practices. The NEC, a cornerstone of electrical safety, offers extensive guidance on conduit installation. Let's consider some key aspects of the NEC that relate to conduit and raceways. Firstly, Article 300.10 addresses wiring methods. It emphasizes the importance of mechanical continuity of raceways and enclosures. This means that the conduit system must be securely connected and provide a continuous path for grounding. Secondly, Article 314 covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handheld enclosures. It outlines the requirements for the selection and installation of these components to ensure proper support, accessibility, and protection of conductors. Thirdly, Chapter 9 contains tables and examples for conduit fill calculations. Understanding these tables is essential for determining the appropriate size of conduit needed to accommodate the number and size of conductors being installed. Using the correct conduit size prevents overheating and damage to the conductors. Considering specific types of conduit, electrical metallic tubing, or EMT, is a thin-walled and threaded raceway commonly used in both concealed and exposed locations. Article 358 provides requirements for EMT installation, including secure fastening and proper support. Rigid metal conduit, or RMC, is a heavy-walled, threaded raceway suitable for applications requiring high levels of mechanical protection. Article 344 covers RMC installation, emphasizing the need for proper threading and the use of approved fittings. Electrical non-metallic tubing, or ENT, is a flexible, non-metallic raceway often used in concealed locations within walls, floors, and ceilings. Article 362 outlines the requirements for ENT installation, including proper support and protection from physical damage. Liquid-tight flexible metal conduit, or LFMC, is a flexible, metallic raceway with a liquid-tight jacket suitable for wet locations. Article 350 covers LFMC installation, emphasizing the use of approved fittings and proper bonding. Liquid-tight flexible non-metallic conduit, or LFMC, is a flexible, non-metallic raceway with a liquid-tight jacket, also suitable for wet locations. Article 356 outlines the requirements for LFMC installation, including proper support and protection from physical damage. Grounding is a critical aspect of electrical safety. Article 250 of the NEC provides comprehensive requirements for grounding and bonding electrical systems. Proper grounding ensures a low impedance path for fault current, minimizing the risk of electrical shock and fire. When installing conduit, it's important to bond the conduit system to the grounding electrode system. This can be achieved by using bonding jumpers, grounding bushings, and other approved methods. The size of the bonding jumper must be determined based on the size of the ungrounded conductors in the circuit, as specified in NEC Table 250.102. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. The NEC limits the allowable conduit fill to prevent overheating and damage to the conductors. Chapter 9, Table 1 provides the maximum allowable conduit fill percentages for different types of conduit and conductor combinations. To calculate conduit fill, you need to know the cross-sectional area of the conductors being installed. Chapter 9, Table 5 provides the dimensions and cross-sectional areas of common conductors. Once you know the cross-sectional area of the conductors, you can use the following formula to calculate conduit fill. Percentage fill equals total conductor area divided by conduit area times 100. The calculated percentage fill must not exceed the allowable fill percentage specified in Chapter 9, Table 1. Bending conduit is a fundamental skill for electricians. Proper conduit bending ensures that the raceway system follows the desired path and provides a smooth, unobstructed pathway for conductors. There are several types of conduit benders available, including hand benders, hydraulic benders, and electric benders. The choice of bender depends on the size and type of conduit being bent, as well as the complexity of the bend. When bending conduit, it's important to follow the manufacturer's instructions and use the correct bending techniques. Incorrect bending can damage the conduit, reduce its strength, and make it difficult to pull conductors. Common types of conduit bends include 90-degree bends, offsets, kicks, and saddles. Each type of bend requires a specific set of calculations and techniques. For example, when making a 90-degree bend, you need to determine the take-up, which is the amount of conduit that will be consumed by the bend. The take-up varies depending on the size and type of conduit being bent, as well as the bender being used. Offsets are used to move the conduit a short distance, either horizontally or vertically. The offset requires two bends, and the distance between the bends depends on the desired offset distance and the angle of the bends. Kicks are similar to offsets, but they are used to move the conduit at an angle. The kick also requires two bends, and the angle of the bends determines the amount of the kick. Saddles are used to bend the conduit around an obstruction. The saddle requires 3 or 4 bends, depending on the size and shape of the obstruction. Supporting conduit is essential to ensure that the raceway system is securely mounted and protected from physical damage. The NEC specifies the maximum spacing between conduit supports, which varies depending on the size and type of conduit. Article 344.30 for RMC specifies that RMC must be supported within 3 feet, or 0.9 meters, of each box, cabinet, or fitting, and at intervals not exceeding 10 feet, or 3 meters. Article 358.30 for EMT says that EMT must be securely fastened in place and supported within 3 feet or 0.9 meters of each outlet box, junction box, cabinet, fitting, or coupling, and at intervals not exceeding 10 feet or 3 meters. Article 362.30 for ENT specifies that ENT must be securely fastened and supported at intervals not exceeding 3 feet or 0.9 meters. Various types of conduit supports are available, including straps, clamps, and hangers. The choice of support depends on the type of conduit being supported, as well as the mounting surface. When installing conduit supports, it's important to use the correct hardware and techniques. Over-tightening can damage the conduit, while under-tightening can cause the conduit to sag or come loose. In wet locations, it's important to use conduit and fittings that are listed for wet locations. These components are designed to prevent water from entering the raceway system and damaging the conductors. When installing conduit in wet locations, it's important to seal all connections and openings to prevent water intrusion. This can be achieved by using sealant tape or other approved methods. In corrosive environments, it's important to use conduit and fittings that are resistant to corrosion. These components are typically made of stainless steel, aluminum, or PVC. When installing conduit in corrosive environments, it's important to protect the conduit from contact with corrosive substances. This can be achieved by using coatings, wraps, or other protective measures. Understanding these key aspects of conduit installation, referencing the NEC, and adhering to local regulations are crucial for ensuring safe and compliant electrical installations.